So I welcome all the participants to the second day of our international conference on computing and communication and learning. So today we have Professor Sudip Misra sir from IIT Kharagpur. Sir will give a keynote on IoT in healthcare from wearable to diagnostic system. So before sir will start, I'll introduce. So Professor Sudip Misra is a professor and INAE Abdul Kalam Technology Innovation National Fellow in the Department of Computer Science Engineering at Indian Institute of Technology, IIT Kharagpur. He received his PhD degree in computer science from Carleton University in Ottawa, Canada. His current research interests include wireless sensor network, Internet of Things. Professor Misra has published over 460 research papers and 12 books. He has won 9 research paper awards in different conferences and 4 best paper awards in IEEE journals. He was awarded the IEEE ComSec Asia Pacific Outstanding Young Researcher Award at IEEE Globacom 2012, California, USA. He was also the recipient of several academic awards and fellowship, such as the Faculty Excellence Award from IIT Kharagpur, Young Scientist Award from National Academy of Science India, Young System Scientist Award from System Society of India, Young Engineer Award from Institution of Engineers, Governor General's Academy Gold Medal at Carleton University, the University Outstanding Graduate Student Award in the doctoral level at Carleton University, and National Academy of Science India, Swarna Jayanti Puraskar, Golden Jubilee Award, Samsung Innovation Award in 2014 at IIT Kharagpur, IIT Biman Behari Sen Memorial Award in 2014, and the Career 360 Outstanding Faculty Award in Computer Science for the year 2018 from Honorable Minister of HRD India. Thrice consecutively, he was the recipient of IEEE System Journal Best Paper Award in 2018, 19, and 20. He was awarded the Canadian government's prestigious NSERC Postdoctoral Fellowship and the Alexander von Humboldt Research Fellowship in Germany. His team received the GYTI Award 2018 in the hands of the President of India for socially relevant innovations. Professor Misra has been served as associate editor in various reputed journals: IEEE Transaction on Mobile Computing, IEEE Transaction on Vehicular Technology, IEEE Transaction on Sustainable Computing, IEEE Network, IEEE System Journals, and other journals. He is the fellow of IEEE, National Academy of Science of India, NASI, Indian National Academy of Engineering, the Institution of Engineering and Technology, UK, British Computer Society, UK, Royal Society of Public Health, UK, the Institution of Electronics and Telecommunication Engineering, India. Professor Misra is the distinguished lecturer of the IEEE Competition Society. He has been serving the executive committee of IEEE Kharagpur section since 2008 in different capacity. Previously, he is the chair of IEEE Kharagpur section. Professor Misra is the ACM distinguished member. He is also the director and co-founder of IoT startup Sensor Drops Network Private Limited. So you can visit to the website of Professor Misra from IIT Kharagpur website. So with this introduction, I request Sudip Misra sir to start today's keynote. Sir, please.
Okay, so thank you very much, Professor Sanjay Panda. So it's very heartening to see that you are organizing a very good conference in NIT Warangal, and personally, I am very much happy about it. And I also see that so you have different audience who have joined this particular session. So before I start talking about this topic that we have selected for today, So can I know, like, what is the composition of the audience here? So are they mostly students or faculty or both?
They are participants of our conference, sir. They are all faculties, research scholars, mixture of all.
Okay. And they are joining from different institutions?
Yes, 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 sir.
Okay. So, so greetings everyone. So I'm going to talk about IoT in healthcare, from wearables to diagnostic systems. I am Sudip Misra, and I lead this FAN lab, which probably many of you have heard about, the Smart Wireless Applications and Networking Lab in IIT Kharagpur. And this particular lab is, as many of you probably already know, is quite renowned, not only in our country but throughout the world, for some of the uh, you know key research works that we have contributed in the domain of IoT. So today, I'm going to talk about some of the healthcare applications of IoT, particularly from the perspective of the contributions that we have been trying to make in our lab. IoT, probably most of you already know, is an emerging technology, and in fact, it is gradually transitioning towards higher degrees of maturity. And globally, wherever you go, whether it is in our country or elsewhere, we are able to see some footprint of IoT applications in either day-to-day lives or in the businesses. So there are so many different applications that we can find. If you are not already familiar with IoT, if you just search in the internet, you will be able to see, like, what all IoT is about and what are the different applications that people are talking about. So let me just, before I talk about the healthcare applications of IoT, let me just give you a little bit of perspective for those of you who do not already know what IoT is all about. So IoT is an acronym for Internet of Things. And there is a whole lot of things to talk about when we talk about IoT, but in the interest of brevity and in the interest of time, let me just tell you that IoT, you can visualize IoT to be an extension of the existing internet, where we are not just simply talking about the interconnection of different computers or the internetworking of different computers or computing devices, but we are extending the concept beyond by including different physical objects that we think that we can see around us, and the ones that we use, and be it consumer devices or be it the devices that are used in the businesses. So IoT is basically the internet working of these different physical objects, which makes it very interesting. Now the question is that why is it interesting? The reason is that so there are so many different applications or so many different use cases that can be served in a very efficient manner if you IoTize the different physical objects, right? So you must have heard about smart cities. So smart cities basically talk about how you can use the IoT technology, and or of course, there are so many different other technologies, engineering and scientific technologies that are used in order to basically build these smart cities, not just IoT. But the point is that so gradually the cities are being transformed not only in our country but around the globe to smarter cities. Now, for this smartness, basically what is done is that the different physical objects in the different diverse application areas of a city, whether it is judiciary, whether it is transportation, whether it is the police, whether it is the hospital, whether it is this public surveillance systems, or whatever you can think of, so the 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 point is that can you adopt IoT technology to make these different application areas of a city smarter? So holistically together, you can think of as a conceptualization of the smart city. Now this is smart cities, but many of you probably have also heard about something called smart homes. Now, smart homes are also gradually becoming popular, and already we have seen different devices, consumer devices that are sold in the market with some some footprints of IoT technology in them. So, for example, there are air conditioners which are sensor enabled, and you can remotely you can remotely control these air conditioners, right? So likewise, there are different sensor enabled systems that are available nowadays, and you can operate them remotely for different good reasons. Now, so coming back to the applications of IoT, so we have seen that IoT applications are there for building smart cities, for building smart homes, and so on and so forth. But so there are so many different applications, right? So whether it is a space, whether it is agriculture, so we talk about smart agriculture, similarly smart healthcare. So now today our focus will be on the smarter healthcare viewpoint. But remember that healthcare itself is quite fast, right? And in our group, we have not been able to do too many things on healthcare, but we have been able to focus on only the use of wearable systems, wearable devices, and how you can use these wearable devices to extract meaningful data, which could be used for for improving the quality of life, or quality of service, or the quality of the systems altogether. So use of wearable systems, and the whole idea is that can you use these wearables to produce systems which would also aid in diagnostics. Now, diagnostics is more deep, but the point is that can you try to achieve diagnostic level systems through the use of these lightweight, small, cheap wearables. That's the whole point. So we are going to focus for the next little while on the IoT applications in healthcare from the wearables viewpoint. Now, a little bit of background. If we look around, throughout the world, there is an increase in population, right? So we talk about India, China, population, rising population, etc. But that's not just true for these two countries. You take most of the countries, and you will be able to see that for most of them, basically, there is an increase in the population. Added to that, we have also seen that there are large number of diseases that are increasing in numbers, and also making people, the citizens, gradually sick, right? So you need doctor's intervention, you need medical intervention, and so on. So while there is a need for all these interventions, we have also seen that again throughout the world, there is an increase of healthcare infrastructure, while the medical facilities and resources are gradually getting restricted. So this is one aspect. And on the other side, so there are so many different scenarios of which have different problems associated with them. So one such completely different scenario is that when we talk about when we talk about patients, right? So let us say ourselves. So when we go to a doctor prescribes medicines, we bring the medicines home, and after that, what happens is that many times we do not take the medicines on time, and that is very crucial, as many of us we already know. So it is very important to take the medicines on time, but the thing is that we will forget, or we are a little reluctant, or whatever be the case. So like this, actually there are so many different scenarios involving medicine and healthcare, where technological intervention can help. So for example, IoT technology itself can be used to improve connectivity, and setting reminders, and so on and so forth, so that the quality of treatment, or the quality of the access to medical facilities can be improved. So the whole idea is that can we build an IoT-based healthcare system that aims to interconnect different medical facilities whether it is the hospitals or whether it is the nursing homes or the different doctors who are treating patients. So interconnecting all of them with the patients through the internet to deliver progressive healthcare services. The whole idea is that we want to build a complete different communication network which is going to offer healthcare services anywhere, at any time, and by connecting any object, whether it is medical object or whether it is a non-medical object. The connectivity is very important between all of them. So we are gradually getting into a scenario of smart healthcare where IoT technology can be used, can be integrated, and it is going to look something like this. On one end, we have the different things which are sensor enabled. So these are all sensor enabled things, and the sensor enabled things throw in a lot of data that passes through the backbone communication network, and the data basically goes to the cloud platform, and at the cloud platform the data are stored, and also different intelligent machine learning and different analytics are executed, based on which different inferences are made, which can be again fed back to the different physical objects from where the data basically come, or to completely different physical objects. So we are looking into some such kind of infrastructure build up, and so the point is that how can we build this now? Before I proceed further, I also wanted to mention one thing, that here we talked about the use of cloud technology. So cloud technology has become kind of now a de facto kind of option that people tend to use when they implement different services, because of the different interesting service offerings of cloud technology. But the problem with cloud, there are many problems with cloud. Now in this scenario, one of the problems with cloud is that the data has to travel from the source all the way to the cloud servers, and that costs a lot of time. Now the communication latency basically increases. Now IoT systems are supposed to be real time in nature, and that is a problem, because if this data will all have to travel to the cloud, then there is a propagation delay, and then of course there are other forms of delays also, which will all add up, and that is not very desirable. So that is the reason nowadays people are talking about the use of edge computing and edge devices, fog devices, and so on, which are going to be closer to the source of the data, and some of the processing would be done at these devices, and the rest of the data which are not time sensitive are going to be sent to the cloud platform remotely. So cloud platforms are normally much more higher processing capability enabled compared to these fog and edge devices. So what are the different types of healthcare services we can get with the help of IoTization? We can get education, like health education, right? So IoT based health education, telehealth education, telehealth data access, because data is very important, right? Any sort of data, and particularly when we talk about medical data, health data, these are even more important. So we are also talking about telemedicine. Telemedicine, we all know, like remotely, in remote parts of our country, patients get treated or patients get attended by doctors who will be situated in apex hospitals in the different tier 1 cities of the country. So telemedicine, telesurgery is kind of a surgical equivalent of telemedicine. And then we have telemonitoring. Telemonitoring is like round the clock, 24/7 continuous monitoring of the patients by the doctor. So whenever there is some kind of problem of one kind or the other, the doctors who are associated with the patients will get notifications about the same. So health education is very important, because so health education is very important. And what happens is when we talk about education, so we have seen that particularly during the last 2 years of the pandemic, we have seen that there has been a growth in remote education, telelearning, telementoring, etc., teleconsultation. So all of these have improved, or the necessity of all of these we have witnessed in the last couple of years. So the whole idea is that can you use these network technologies to enable knowledge delivery anytime and at anywhere. So telehealth education by remote research initiatives, setting up adequate cyber infrastructure, collaboration, demonstration centers, remote clinical trials and camps. So all of these are very crucial to telehealth education. So the whole idea is that we are going to build platforms for medical education and training to the healthcare service providers from which can be accessed from remote locations around the globe. So the benefits of having a decentralized kind of platform would be that because it is decentralized, there won't be any single point of failure, and together holistically we can offer round the clock support, and we can also have diversified management of the system. TeleHealth Data is another important service from these IoT-based systems. So basically, health data. I mean, data in general, access to data is very crucial, and that many of us already know. Now, health data is very important because that helps in a number of different ways. For example, if you have adequate levels of data, these data can be processed at different levels to help the doctors in their treatment and diagnosis. So telehealth data basically is in this case it is important because you through these wearables and connected wearables, etc., continuous streaming of data comes. So this data, how do you store the data, how do you use the data? So that's very important. So you can create databases, knowledge bases, etc., of this data which could be used by the doctors or the practitioners as and when needed, allowing them to deliver effective and timely care. So there are different challenges of this kind of approach. So basically, so you need access to this kind of network, a high performing broadband kind of network. You also need trained workforce, and also you need awareness in the remote and rural areas of the country. Telemedicine, most of us have heard about this term because this has been around since a couple of decades now, although not involving the modern day IoT devices. So telemedicine basically provides skilled remote consultation to the remote patients, then assist the remote primary care physicians in delivering a diagnosis. So basically, what happens is you have the doctors sitting remotely, and remotely they monitor the different patients like this, and these patients and the doctors would be geographically separated, and typically, so they could be not only geographically separated, but long distance away. It could be sometimes even cross continents. So this sort of thing we are talking about now. So telemedicine basically provides this kind of a skilled kind of consultation with the doctors by the patients, and then the patients get billed for the number of the amount, the duration of time that the doctor has spent with the patient. TeleSurgery is another very important thing because gradually what is happening is that surgical precision is important, and telesurgery basically can help in this surgical precision. Now the problem is that if you want to conduct surgery remotely, you also need to take into account that whether you have a high bandwidth kind of line which brings a lot of important data in near real time, or maybe in real time. And because as you can understand, like if the data arrives even like microseconds delay, then also so the precision with which the surgery has to be performed may be affected. So real-time surgical collaboration among the surgeons from different healthcare organizations is also possible with the help of telesurgery. And there are tele-robotics technology that are available nowadays, which can help in safe, precise surgical operations, and that can enable the surgeons to perform the surgery on a patient who is sitting remotely, right? So So like this, actually there are so many different telesurgical technologies which are gradually becoming popular. Telemonitoring, holistically, use of wearables. Patients wear these wearable devices. Continuous sensing of the data happens. Now you have to sense the data, you have to collect the data, you have to monitor, and you have to send the patient's physiological data over the network to a healthcare provider for remote analysis. This telemonitoring is useful because you can automate and you can keep certain scripts which alerts the family or the doctor about any abnormal health condition. So these telemonitoring basically systems are classified into different types: wearable devices, non-invasive data collecting devices, composite systems involving both invasive and non-invasive integrated systems, basic analytic and decision support systems, and recommender systems. While IoT was getting popular, a very important cellular technology was also becoming very popular, which was called the 5G, which is called the 5G. Now, since the last several years, 5G technology has started becoming increasingly popular, and we have also seen that in the last, 2 to 3 weeks, we have seen that our government also launched the 5G services. Now, the advantage of 5G is that with the help of this technology, you can connect massive number of different devices running different applications. Added to that, 5G is a high performing, high capacity technology for communication, wireless communication, cellular communication, and 5G offers ultra low latency. Similarly, 5G also offers ultra high reliability of transmission of data transmission, and also offers high data rate, energy efficiency, spectral efficiency, and so on and so forth. So all of these are very important from an IoT viewpoint also, because for IoT, and particularly when you talk about applications like healthcare, so here latency, ultra low latency is a benefit, because if you're talking about near real-time kind of transmission, then so a lot of problems basically you can overcome with the help of this approach. So plus ultra high reliability is also something which comes as an offering of 5G. Ultra high reliability means that you are not going to get any packet errors or packet drops and so on. Okay. So what are the opportunities? So 5G technology has been going to be popular. 5G can be used in the backbone. So remote robotic surgery, for instance, decentralized patient care beyond hospital setup, use of augmented reality and virtual reality, which have become very common and very popular technologies nowadays. The integration of AR/VR technologies for performing complex medical procedures is a possibility. And it is also possible to, with the help of 5G, because of the enormous bandwidth that it provides, it is possible to transmit easily and fast, basically, the large data files such as X-ray reports, CT scan reports, sonography reports, and so on. So what does 5G in healthcare bring as opportunities? Huge opportunities. So for instance, patient applications, this is the maximum share that, the patient applications take the maximum share in terms of the revenue by the introduction of 5G technology in healthcare. Second is hospital applications. This is the second bigger one of the pie. And then we have other medical applications and healthcare data management. So this is kind of the fragmentation of the revenue that is expected by the year 2026 with the introduction of 5G technology in the healthcare industry. So these are some of these wearable devices. As you can see, I have been constantly talking about wearable devices. These devices, they look like, these are wearable, right? So if you are putting them on your wrist, they look like wrist watches like this one. These are some of these different wearable devices like Jawbone, Fitbit, Misfit, Withings, and so on. So these are some of these. Then there are many other wearable devices also nowadays, like headband and gloves, and so many different wearable devices. So these wearable devices are fitted using very high technology. These are fitted with different sensors, and these sensors basically collect the data, and then that data will have to be processed further to draw meaning out of them. Non-invasive devices. Uh, so you see that when we talk about this kind of wearables, etc., right? So these could be again classified into two types: non-invasive, which is the most common type. In non-invasive, basically, there is no surgical operation or anything that is performed in order to put these IoT devices into the system, into the human, right? So the data, basically, these are also enabled with communication mechanisms, and so the data basically will have to be sent remotely for further analysis, right? So these data could be like body temperature data, pulse rate, blood oxygen, blood pressure, ECG, EMG, and EEG, and many other physiological parameters that could also be monitored with the help of these wearable sensors. These are also fitted with different communication mechanisms, whether it is Bluetooth or Wi-Fi or LoRa or whatever. So these are different communication mechanisms that are fitted with them, so in order to have either personal area network kind of PAN, LAN, or even WAN range of transmission. So these devices, basically, these non-invasive devices are gradually becoming very popular. There are a lot of different IoT-based systems that are built using these non-invasive devices. One such popular system is the WISE. So this is the architecture of the WISE system. So on top, we have the sensing layer. As per this particular architecture, on top, we have the sensing layer, networking layer, data processing layer, and the application layer. And for each of them, basically, these different technologies that work in them are mentioned over here. So what happens is that these sensors like ECG, blood pressure, GPS sensor, etc., they collect the data, and through these different parts of the network, the data are sent for further data processing, and then the processed data are sent to the application for use by them. So, like WISE, InterHealth is another system that also was published a couple of years back. So, in InterHealth, basically, we are talking about again human lifestyle monitoring in a decentralized mobile fashion, so that different health issues from food, physical activity disorders, etc., could be prevented. So it integrates two specific IoT platforms, the Universal and Body Cloud. So Body Cloud is like the cloud equivalent for storing medical data. And this Universal is the one that helps with weighing alerts, weight alerts, blood pressure alerts, online questionnaires, blood pressure measurements, weight measurements, and physical activity measurements. Composite systems. So composite systems are basically not only comprised of invasive devices, but also non-invasive devices, but also they include the invasive devices. So for example, blood glucose monitoring, right? So there is a glucose sensor, and that sensor is invasive. And like that, actually, there are different other sensors also, physiological sensors, which are non-invasive in nature. And so basically, what happens is the data from both the invasive and non-invasive devices, they come in, and further the data are sent to the cloud for further processing and further more continuous monitoring. So we are talking about different types of sensors, such as the body position sensor, ECG sensor, airflow sensor, EMG sensor, body temperature sensor, body pressure sensor, glucose sensor, and galvanic skin resistance sensor. So these are the different types of sensors that are typically used in these kind of systems. So these data are invaluable. So you can have decision support systems built using the data. So based on the historical data from this and similar other patients, so a lot of different analysis could be performed, and these data are stored, and finally they are processed in order to build these knowledge bases. From the knowledge base, you can perform different sorts of analysis, different types of engineering you can perform on the data, and then so these systems can be used to offer diagnosis, therapy, then prognosis and education. So these recent support systems have been built quite extensively over the years, and many of them are integrated with IoT systems. But the thing is that they could be used for different purposes. So you can have recent support systems to assess the cardiovascular disease risks. You could also have recent support systems for monitoring the the occurrence of cerebral strokes in patient and so on. So like this, like decision support systems, there are even in a higher level of popular systems nowadays, which is called recommender systems. These recommender systems basically not only collect the data and build some kind of a digital inventory, but also they ensure that these recommender systems basically help in recommending the different can help in recommending the different problems that might occur in the patients, right? So like that actually, and also like different types of other recommendations would also be performed. So typically there are these three phases in a recommender system. First is the information collection phase, where you are collecting all the information from the different data sources. Then there is a learning phase, and then there is the prediction or the recommendation phase. So recommender systems have been built for diabetes monitoring, predicting, and so on. Recommender systems have also been built for use by the doctors to do number of automated tasks. For example, automated matchmaking between the patients and the family doctors could be used for examining the frequency of patients' interactions with the doctors, and so on and so forth. So like this, actually, you could build recommender systems for any identified problem. So recommender systems have already been built for drug recommendation surveys. Cloud-assisted drug recommendation is one such drug recommendation service, and it recommends patients with top N-related medicines according to their symptoms. ProTip is another one, which is for food recommendation system based on hybrid filtering mechanisms such as collaborative content and knowledge-based. So content-based filtering is based on the comparison between the content of the items and user profile, and knowledge-based filtering is for recommendations based on specific queries made by the user, and so on and so forth. So in the interest of time, basically I'm skipping the rest of the details, but you could interact with me later on to get a better understanding of these in further detail. So what are the benefits of integration of IoT or adoption of IoT in e-health? So to offer immediate alert during medical emergencies, to reduce the physical need to go to the healthcare facility, eliminating the geographical barrier for rural and semi-urban regions, offering ubiquitous and wide range healthcare facilities via virtual presence, early detection of any anomaly in the monitored physical data, and prediction of any disease from the detected anomaly. So now, very quickly, I'm going to end this talk by giving you some idea about some of the systems that we have built. One of our very well-known popular system that we initially built is called the AmbuSense system. In our SWAN lab, we built the AmbuSense system that can offer continuous end-to-end monitoring of patients who travel for long durations of time in ambulances without any medical care or medical attention on board these medical ambulances. So this AmbuSense system was built, and it can offer telemedicine and remote healthcare, can help in reducing the emergency response time, can help in real-time patient status monitoring and digitized medical history. Because of the success and the popularity of the AmbuSense system, we evolved AmbuSense and we built AP1. Now, AP1 is more like broad spectrum in terms of the different things that it can do. So here is a list of the number of things that AP1 system can do. So AP1 got evolved from version 1, version 2 to AP1 NG, which is one of the advanced versions of AP1 with additional features. And there is on-device visualization. Then we have touchscreen enabled device login, and we also have fingerprint authentication and login. So there are many different other features: biometric authentication, fingerprint-based login access, plug-and-play sensor integration, touchscreen interface, and live data visualization. So that's basically the AP1 system that we have built. AP1 uses number of off-the-shelf wearables and then builds the system across by integrating all of them together. But remember that this integration exercise has been for us, it took 4 to 5 years. So it's also not a very easy thing. Smart digital stethoscope. Basically, it's kind of an equivalent of the stethoscope that doctors use, but here we are not only talking about normal analog stethoscope, but the digitized version, which would be visualized by the doctors, and also these digital stethoscope could be used remotely as different sensors to collect different data. Okay, so that's all. I have taken slightly a little bit more time, but I think more or less it is okay. So I just wanted to conclude by thanking all the students who work in our lab, and many of them, the faces that you see, this picture is a little dated. So some of them that you see over here have either become faculty in different institutions after doing PhD from here, or many of them are still doing postdocs and so on and so forth. So and we also have a newer picture which will have to update over here. But all I wanted to say is that all these good works were done by our students only, and I take the privilege to present their works like this in different conferences, workshops, and different different venues. So thank you so much. If you have any question, I would be happy to take for the next